So, thank you guys for coming late on a Tuesday afternoon here. The title of this session is Keeping the Internet of Things Promise, Connecting Customers to Products, and true to the title of the presentation, I have a customer up here. He and I have been working together. This is Marc Behr from Emerson Climate Technologies Group. And we have been working together for what, 2 years?
2 or 3 years
yeah,
so far.
2 or 3 years. I'd say Marc is probably the quintessential trailblazer with regard to his ability to understand what we're doing here at Salesforce and also building out new use cases for IoT. In the course of this talk, what we're going to do is I'm going to present to you what it is that Emerson is doing with their IoT use cases, and specifically what they're doing in their cargo division, because this is the thing that is currently building right now. Then we're going to walk through a complete build. You're actually going to see everything from soup to nuts. This is the platform events. This is the context, the orchestrations. And when we're done, you're going to have a complete POC use case. And we have all the resources, the GitHub code that makes our electric imp work, all of the metadata from the org, a video walkthrough, screen caps, et cetera. So if anyone's interested in understanding what it is that makes IoT tick, that's what you're going to be getting out of this. So to just get started here, we're going to dive in. So this is where we started 2 years ago at Dreamforce with Todd Finders, who is the CIO over at Emerson Climate. And what they wanted to do was become more proactive in the way that they interact with customers. Little known fact, when HVAC units are installed in residences, there's a very high failure rate of installing them correctly. Now, you might say, well, how is it possible that they would have this high a failure rate when they go and install an HVAC unit? Well, you actually think about the reality of the situation. You go in and you install an HVAC unit in Atlanta in July. You're probably not going to turn the heat on full blast, for instance. But you're certainly going to do that in January to realize that those heating elements aren't operating at peak efficiency. Similarly, when you get your bill for the electricity usage for a particular HVAC, it may be rated for 92% Energy Star rating, but if it's slightly misconfigured, it could be using a lot more energy. And that's what we mean here when it's not correctly configured. And so what they did was they put a lot of sensors on these devices and helped their technicians better install these and reduce the number of misinstalls. So that's where we started. And I want to keep moving here because this is what it looked like. I think this is like, what do you think, Mark? Rev 1, Rev 2?
Yeah, that was pretty early on, probably close to 2 years ago when we started the process.
This is very early. We'll show you actually a screenshot of what ended up happening with this one. It got very complex and very interesting. It's connected to a custom application. I'm not going to, again, dive too deep here. I just wanted to give you guys a sense of where Emerson started and the process whereby we arrived at the current POC. So Emerson, we just launched the Iot Explorer product, and we are proud to say that Emerson was actually the first customer that purchased it. You guys actually, I think, bought it before the SKU was live.
Yes.
So that was interesting. So we're really pleased to be working with them again, with Marc in particular, working on additional use cases here in the new product. And let's talk about what we're going to be doing here. So Emerson, they're going to be using one of these devices to monitor the temperature of shipments of produce. So now I put a picture of raspberries up here because this is actually a 6-figure problem. If an HVAC unit fails while there is a transport of fresh produce, berries in particular, this can cause thousands and thousands and thousands of dollars of loss. And what they want to do is put temperature sensors into these into shipping containers so that they can monitor what's going on and basically alert people downstream in the distribution chain. So this is actually a real device. This is a real use case that we're going to be building out, and it has real impact to Emerson. What we're going to be doing, what the business impact of this, because Salesforce IoT is all about monetizing IoT. And this is our business impact, which is reducing expensive food spoilage and improving transport efficiency, because we now can be a little bit more proactive about when a shipment is containing spoiled food. It's not a surprise when you open the door and realize that HVAC unit hasn't quite kept the temperature where it should be. So with that aside, I want to just breeze through that so we can actually show you the product. And to do that, I'm going to actually so Marc is going to walk us through why we're building it in the way that we're building it, and sort of his perspective into the product and how it interacts. I'll interject where necessary, but I'm going to be his click path. And as I mentioned at the end of this, we're going to be able to pick up this electric imp, and we're going to make some real-time events happen. So with that, let's go ahead and transition over to the actual org.
Yeah, just to clarify, this is the device we use, but we're going to use the electric imp today just because we have a lot easier for us to control it. The other one requires a 3G connection, and it's not as easy to get in the building here. So we're using the electric imp to simulate what we would normally do. Mm-hmm. So I don't know how many of you have ever tried to find the Iot Explorer. It's in most of the orgs now as of Winter 18. You should be able to find it if you go into your setup menu. So we'll go look for that, and you should find Iot Explorer, the Salesforce IoT. That's what we're going to be working with today. And first thing we have to do is it works by using platform events. So it's the same platform events that you've seen for other things probably. And this is just allows us to get the data from the outside world back into Salesforce for whatever reason. Platform events are a subscriber receiver kind of protocol. So anybody can write to the bus and anybody else can read off the bus. So if you're interested in getting information off of it, you would just take a look at the bus and subscribe to it, and anything that comes in you'd see. So what we're going to do is we're going to create a couple of custom fields on this platform event. The first one I think we're going to do is the text field. So that's going to be the serial number of the unit. So every unit obviously is unique, has a serial number in it. So we want to make sure that when the platform event is running, we know which one this is referring to. What we've done in the background is we've tied this particular serial number to a unique field on an asset. So that's how we're going to tie these things together in a few minutes. The next thing we need is we want to know what the temperature is. Otherwise, it's kind of useless. We have no idea what's going on. So we're going to put a number field in there with the temperature that we're going to be able to send in. So when we start to talk to the platform event, we'll be able to get the data. And the beauty of platform events is because they just look like Salesforce objects, you just can use the standard REST API without writing any code in order to be able to push the event data directly into it. All right, so now that we have the platform events, the next thing we have to do in the Salesforce IoT is create what we call a context. A context ties a platform event to something else inside of Salesforce. So, like I said, we're going to be tying this, in this case, to the asset. So we want to be able, we'll specify what the key type is, so we know what we're looking for. In our case, it's a string. So there's the asset, and then the tracker ID is that unique identifier that I said I put in there so that we can tie these two things together. All right, so now we have the context. Now we tie the context itself to the platform event that we had just created. So this is this is finishing the tying everything together so we know what everything refers to, and we can save that.
All right. I think that's all the exciting bits upstream of the orchestration.
Okay, yep. So now we get into the orchestration. This is where the actual real work is being done. So we're going to create a new orchestration. And the context, it's, again, now you have to specify which context you want this orchestration to actually run on. So we'll go ahead and get that started. We're going to create some of the rules. Now, the Iot Explorer, same as the IoT Cloud itself, is a rules-based engine. So we want to be able to write the rules to get it to do what we're looking for. In this case, we're going to have a start rule and a warm temperature rule to start with. And the start rule, we specify, the first column is when, so you specify what you want to be looking for. In this case, we're looking for that platform event called DF17 that we created. Platform events you can identify because they end in the __E. The next thing in the condition, this is telling it, well, what do we want to do? What is it we're looking for? So what we're saying here is if the temperature is greater than the warm temperature that's defined in the asset, and less than the hot temperature that's defined in the asset. So on each asset, we actually define a unique temperature range for that asset. So if there's 5 different shipments going on, for one shipment, maybe the range is from 30 to 40 degrees. Another shipment may be 50 to 60 degrees, just depends on what the product is. So we want to do that in the asset so that we don't have to write the orchestration as a different orchestration for each one of that. Each product that we might be shipping. So this is what that allows us to do that. So then the next thing, is we're going to, for the first thing we want to do, I also created a second, and we did this in advance, platform event called the debug event. And we just did more to show you that, the Iot Explorer can also, in addition to reading platform events, it can also generate them. So we're going to send this out. We're going to put out, there's two fields on it, the temperature and the message. And we're just going to take the event data and put that into the temperature field. And then the message can be whatever text you want, because that's what that is defined as. So we're going to go ahead and say that there's and you need to put in the text thing, right?
Join.
Yeah. Oh, no, that's a track radio.
Yeah, I'm pretty sure I got that.
Okay. Then the action name is just what we're going to call whatever. Everything has to have a unique action name or just some way of uniquely identifying it. Now we're going to transition when that occurs. So the temperature is greater than the warm temperature but less than the hot temperature. The transition says, well, what state do I go to next? And so we're going to say, well, that's what we've defined as our warm problem. So we're going to go into the warm state. So once we get into the warm state, now we're going to, again, take a look at the platform event, the next event that comes in, and we're going to create a case. Because now the platform event. No, the case, right, yeah. We're going to create a case, because now we know that the problem's occurred. We've already sent a message out to the debug, and so we want to now create a case telling the agents that this has occurred, and we're going to put some of the details in there. So we got the asset ID, so the case itself will be tied directly back to the asset that already exists inside of Salesforce, and then we're going to put a subject in there. You could put a lot more fields in, but just for the purposes of this demo, we're going to stick with a couple of fields. And this is the one we have to put it into the text, because what we're doing is we have to convert the number field into a text field in order for it to be accepted correctly. It doesn't auto-convert for you.
Right.
The next thing, we want to save the data that comes as a result of this. We could have saved it on the platform event, but we don't really care what happened, and we don't need the user ID or the platform event ID. But in the case situation, we do want to remember what was the case ID, because we want to pull that back. So that's what we're doing there by the response name. Whatever the data that comes back from Salesforce, that will get put into this warm case variable that we're going to use in a few seconds. And then the action name is just what do we want to call this action. Again, you just got to have everything's got to have a name to it. So we save that. Now we're going to duplicate the warm one into another one called hot temperature. This is one of the nice things that you can do with this is when you start getting and you're developing it, you just say, all right, I'm going to take what we have already and I want to duplicate that, and then we're going to just go in and change a couple of the variables in there so that that's what's going to gain us a really quick development time. So putting this whole entire thing together, all we're doing here is we're going to change the word warm into hot and change the case that is coming back as the hot, and save that.
Yep.
All right, and there we're going to, so now we're going to duplicate just the rule part of this other state. And again, being lazy, I don't like to have to type more than I have to, so we're going to just duplicate that. And here we're going to say, now instead of the temperature being in the warm range, if it's above the hot temperature, we want to be able to detect that. And we're going to change what happens in that case from the warm alert notice to a hot alert notice, and the only difference, again, is what we say. And once we have that,
there we go.
Save the transition. In this case, we're going to do a transition to the hot temperature, because that was what we defined it as. Yep. So now we have all the pieces that we need. Did we want to put a return in the other one? In the warm? Yeah. Transition. We're going to transition that one back to start just because it makes a pretty picture at the end. I like it. No real good reason. All right, so now that we have those two cases that were created, or potentially cases that were created, we need to store that data that came back from it. And so what we're going to do is we're going to create some variables. There's going to be a warm case ID and a hot case ID. Those are the variables where we're going to store just the ID portion of the case. Because when we created the case, a lot of information came back. The only thing I'm interested in is what was the value that came back for the ID. Because if we want to update the case later on, I need to know what the case ID was. So we have that ability to do that. So we take the warm event type or the hot event type. We're going to do a custom value. And custom value just means you're not trying to do aggregations and value, some of the standard built-in manipulations that you can do with the Iot Explorer. The big reason that we're doing this, and when we go back in a minute, we're going to go back into the orchestration, we don't, once a case gets created, if we don't put this step in there, every time that same shipment has a hot alarm, it's going to generate a brand new case. Well, if it's every time that we're sending the data every 10 seconds. I don't want a new case every 10 seconds while the temperature is too hot. So what we're going to do is in the orchestration, we're going to go back and add in the if part of the rules and say, if where we're creating the cases, in the condition, we're going to add another, the condition is going to be,
sorry, this is,
there, if the hot case ID is null, so that means that if we haven't already created a case, then we're going to go ahead and do this. The other thing we're going to do is add in another rule here, and that rule in this case is going to say for when we don't have the case ID. So in that case, we're not going to do anything, but we're just going to transition back to the start state so that we're ready to go again.
Right.
And we're going to do the same thing with the hot temperature. So we're going to duplicate that one and put the hot check ID in there and then duplicate it. Again, just trying to avoid having too many duplicate cases for the exact same thing. There's a lot of things that you can do under the cover that we're just don't have time to try to get into all of these things. But this will at least give you an idea of some of how easy it really is to put together the entire orchestration from beginning to end. We're just about done.
Anything else there? I think we actually got most of it.
Yep. If you take a look at the state diagram, just so you could sort of see, that doesn't look right. The hot temperature should have gone to exit.
Yeah, that's correct.
That's right. Like, that doesn't look like the picture I like.
All right.
That's correct. That doesn't go to start. That went to exit success. There you go. Now, that should give us a pic. There, I like that little picture.
Okay.
I'm just weird that way. But I just thought that looked cool. All right, so we're going to go ahead and save that. The saving it tells us that there was no errors, so that's a good thing. We got it all typed in correctly. And then we can go ahead and activate that orchestration. We're done. That entire orchestration is now fully ready to go. So we can go in and take a look at the traffic view, and you can see this is what it looks like as data is coming in. So hopefully in a few seconds, the electric imp will generate a packet for us, and we'll start to see that it's entering it into the start state. And if depending on what the temperature is at the particular time it took the reading, there's the start. All right, so we can see that we're now started the orchestration. And if the readings get up too high, it will go into the warm temperature or into the hot temperature.
Do you want to do the honors here?
Yeah, so to simulate that, I'm going to stick my finger on the temperature sensor to push the temperature up a little bit so that we don't have to wait, because if it gets any warmer in here, I may pass out. So hopefully that was enough of a temperature increase that we should go into the warm temperature with the next reading, which just occurred, so that'll take a second. One of the things I just learned from a developer of this product yesterday was this screen only updates once every 10 seconds, or 15 seconds, she told me. So regardless of whether or not the data's come in, the data on this screen will only update once every 15 seconds. So the processing is still going on in real time, but the data showing up on the screen may take a little bit longer for it to show up.
Correct. And while we're waiting here, because it's, as Mark mentioned, it's 15 seconds. There we go. We're in our warm temperature state here.
So if we go back over to the asset itself, we should see, refresh that page.
We get to see all of our data here.
Yeah. Basically, I'm using a couple of different, see, it actually created the case already. You can see the case there. And there's a couple of different Lightning components that are involved with showing the asset. And there's our case. So again, we didn't put a lot of information other than the subject, but you can see that did get tied directly to the asset, so it is tying all the pieces together for us. And
Yep. And then if we go over, let's go ahead and simulate the actual hot temperature.
hold that even
honors
further.
there. Yeah.
That one. Hopefully my body's warm enough that we can get that up there to.
And then once we get done here, we can talk about a little bit about sort of the forward-looking, like other aspects of the orchestrations that you might want to use and that might be useful to you in creating real-world use cases. So as we mentioned here, this is definitely a POC use case. And the intent was to allow you to build this quickly front to start. I mean, as you saw, we just built this in what? It's like 15
minutes or so.
Even. It's a real quick build, which was the intent of the session was to show you a very quick POC, and then we can talk a little bit more about the way in which this product can be used for more real-world use cases. So if we go back over here and check our cases again, let's see.
I held my finger on it.
Oh, you didn't? Okay, well, there you go. So the other way you can simulate cases here, of course, is you can just use Workbench. You can use any sort of REST client that you're interested in to do this work. Obviously, the imp is pretty cool because you actually get live event, live device data, but it's not strictly necessary. So I think no, it's not quite warm enough. All right, well, I'm just going to dive in and start talking a little bit more about the features kind of that extend the orchestration model and discuss a little bit about how you might be capable of using those and how they might apply to additional POCs. So what we showed you today was this is all we're just doing simple event detection based checking against a rule and then doing a simple action. But I don't know if folks caught it here in the audience, but it's not just cases, it's not debug objects. Anything within Salesforce, any object, be that a custom or S object, can be modified, read, or deleted here from the output actions. So when I typed here, I did this a little bit quickly earlier for the purposes of making it simple. But you can see here that any object within the system is capable of being manipulated. Similarly, you could go and create platform events. And I'm going to get to that in just a moment about how that might be very useful for the construction of orchestrations. Before we moved into that, though, I wanted to talk about the way in which we set up our variables earlier. So what we did when we set these up was we're just doing a raw assignment. So the device that sends us a temperature, we assign that to a variable, and then we use that variable in our conditions, which is great. But it's also possible that you might want to do aggregations. And for most of the use cases that we see in production, these become extraordinarily very valuable because these are rolling windows. So for instance, you can set an average if you were interested in not just that raw value, because let's face it, temperature could easily spike within a container, or it could plummet as the unit turns on, depending on where the temperature is, the actual reading is being taken. You might want to just wait for a moving average, or the maximum over a period of time. And that's exactly what you're capable of doing here. So for instance, you could say, I want the average of this particular event field over a 10-minute, 20-minute, 30-minute, hour-long, whatever, period of time. And then let's go ahead and talk a little bit about the platform events, which I'd mentioned a moment ago. So we said we came in here and we created these records. You can create platform event records, or regular records in Salesforce like any other. And this leads to a use case that I think is extremely important. It's a basic design pattern for Salesforce IoT, which is what we refer to as orchestration composition. And you can see this a little bit here because we have two orchestrations. And you could imagine that the temperature monitoring orchestration and the transportation monitor orchestration could be speaking together. For instance, the temperature monitoring could send events out that could then be reacted to and acted upon in the transport monitor. But it's a little bit more advanced. We didn't want to show that directly here. We've got a few notes in it in the documentation that you can check out. So that's a little bit more about variables. Global rules, we didn't touch on this. But it's possible that you might have a rule. We have this entire rules interface here wherein you can write conditions, have actions. But it's possible that a rule might want to be, you have 30 different states. We'll show you our mature orchestration, and you'll understand why this is so valuable. You might have a rule that says, for instance, if a certain particular error code is received, we know that is extremely, extremely important. It supersedes everything else in your orchestration. And you don't want to go and write that same rule state after state after state. You want to specify it once and have the system react to that. And that's what global rules do. So for instance, we could say in this case that when we receive a response event and the temperature, I don't know, is over 300, I don't know how that could possibly be the case, but if it is, you might want to do something drastic. And you might want it to happen no matter what state you're in. So we've covered variables, we've covered aggregations, we've covered global rules. The one thing that we haven't done a lot of doing is describing, this is actually, I think, comparatively important when we talk about the life cycle of an orchestration. What we just did was we wrote all the rules in this declarative interface. But as Marc can attest, when you build an orchestration that is going to get used, iterated upon, improved, and then released by someone else in your org, it's good to document your orchestration so that other people can understand what it is you've done and why you've done it that way. So you can do that here. You can see the descriptions. And then I mentioned over here in the states view because those descriptions then get bubbled up. I think this is really important because this is the explanatory step where you can get someone else in the room and say, well, I've implemented I've implemented my warm temperature, hot temperature case so that we can monitor raspberries. And they'll say, okay, that's great, but what exactly have you done in your orchestration? You can say, well, this is exactly what I've done. So it isn't the most developer-focused view, but it is, in my opinion, one of the most communicative views into the rules inside the product. Okay, so what we're going to do now, we're going to back out a little bit. I'm going to show you what it is that we just built. I'm going to show you a little bit of what the Emerson use case is. And then we tried intentionally, we only have a 40-minute session. I wanted to leave 10 minutes for Q&A if anyone has questions. So we only have 5 minutes left, and then we'll do Q&A. So going back over here. All right, back into presenter mode. Okay, so this is what we just built. Pretty simple. I challenge anyone in this room to go and build what we just built. I think it's really valuable. It's really useful to get your hands directly on the product. As I mentioned, we'll provide all the assets. Please do go and check it out. This is just an overview of what it was that we just built out. And then I'm going to show you actually what the actual POC looks like inside Emerson's org. So this is our little simple one. So this is what they actually did. You can see they're still reflective of the warm and high temperature states. You'll see there's one additional, but when you go over to rules, it's a little more complex. And this is actually just the top section. And I don't know, Marc, did you want to add any comments here? Or what was it?
This is basically doing the same sort of thing, but there's a lot more little tests that I'm putting into it at this point to try to find, to save more information and be able to transition the states a little bit cleaner. We're also not popping out of the states as quickly here. Purposely, if the temperature remains in that temperature range, it'll stay here. But we also have global rules in this one where if the temperature were to go into the hot one when it was in the warm, I want it to come out of it at that point and switch over to the correct state so it's giving us the right information.
And I'd also add that Marc has done a lot more. I think you can see, the rules are a little bit hard to read, and actually I think I provide the screenshot in the zip file that I'm going to be posting to Chatter. But you can see that there are additional, the rules can become a little bit more complex than what we just wrote there, in addition to just those aggregations that I mentioned over in the variables. So this is a view of the temperature. This is actually what Emerson built in their first case. So contrast this with what we just built, because this is what's actually capable.
Took about 5 minutes to build. No,
yeah, we did this in 5 minutes. I don't remember what the rule count was on this, but it was very, very high.
This is actually the one that's still running today. This is where this particular orchestration is what monitors for HVAC, what we were talking about at the beginning, with HVACs, where we're trying to find out whether or not the installer, when they left the scene, actually did their job. And the installers have to stay on scene now. We're telling them, when you install this, we want to make sure that you're installing it correctly, so you need to stay until this runs. This orchestration, as you can see, is a wee bit more complicated, but it also has inputs coming from not only our device, but also from an application that they have on their phone. So every time that they tell us that they're going to be running the heating test, that sends another event into the orchestration that tells this orchestration that, hey, you should be running the heating test at this point. And then it's also looking at the information from the thermostat. So there's a lot of inputs that are coming into this to figure out whether or not the installer did the setup correctly. So we don't want them walking away telling you, oh, yeah, everything's fine, and when they really didn't charge the AC unit correctly, because this is what we're looking for. Some of these states that it's in, I had to get really creative, and because one of the things that we're looking for is what we call steady state. So just when your air conditioner first turns on, or your heating unit first turns on, the difference between the input temperature and the output temperature are pretty much the same. Nothing's happened yet. So what we wanted to be able to find is, well, when does it finally stop changing? There wasn't an easy way of doing that with the way the orchestrations work. So I had to make up some really convoluted algorithm that sits there and watches it over time and saves all kinds of variables. There's, I think, 75 or 80 variables that I have here in this orchestration that where I'm looking for, as the temperatures come together, at some point they stop. The difference between them stops changing. That's what I'm looking for. Once that occurs, then it goes through and takes a whole bunch of readings. So you can make these really simple or really complicated depending on what your use case is.
Yeah, and actually to Mark's point there, one of the things that we've talked about, and I had wanted to mention here at the end, because we built a little tiny thing, and then I was talking about orchestration composition. You could imagine, just like you might refactor a block of code, you might want to refactor this into smaller orchestrations that do focused things. Right. For instance, there could be a heater check, there could be a cooling check, and those could be separate orchestrations that display in that record view when I was looking at orchestrations and setup earlier. But yeah, it's certainly, Mark, probably, I think you might have known the product better than me at various points. You give me a call and ask me about some sort of variable instantiation rule, and I'd be like,
wait, I'm going to have to get back to you on that one.
I'm going to have to look at the code
for that. You're the product
one.
director. What do you mean you're going to get back to me? I shouldn't be asking you questions you don't know.
So, yeah, Mark has always been very much in the weeds and
I'm very
helping us out.
friendly with most of the engineers on the IoT team.
He's been an enormous help. So I want to make sure that we hit this. So these are the resources I'm going to post. Anyone that's interested can go ahead and check out the Chatter post for this, and you can go ahead and gain access. I've already posted the YouTube link that does the walkthrough of that, the little tiny build that we did, and the imp code that Mark wrote for this. And then I will do a metadata export, and there are some screenshots that you can take a look at as well. So all of this is going to be really easy. My goal with this session, we had 40 minutes, we've used 30 some of them. My goal in this session was, if you go down to downstairs in the dev campground and you go and talk to someone at the IoT booth, or you go to an IoT session or see some sort of IoT marketing material, they're going to say, oh, orchestrations are super easy to set up. You can do it in minutes and hours. And you're going to say, yeah, really? And I want you to this is proof positive that anyone can go in and do this really, really quickly. You can imagine giving this tool to folks outside of your engineering teams and saying, you know what? You don't have to have, you don't have to be able to push to master to go and make changes that make my business money using IoT. You can do exactly what we just did and be more proactive in service, sales, and customer engagement. So with that, I'm just going to turn it over. If anyone has questions, happy to answer them now. Otherwise, we can let out a few minutes early, give you time back.
Iot Explorer launch partner, and we had
Yeah.
some problems just the recent days that the orchestration froze.
No, it didn't freeze. It didn't freeze. I don't know what you're talking about.
You just think it froze. It looks frozen, but it's really not, yeah.
No, Accenture? Okay, actually, this is a really good point. So the question was, the orchestration seemed to have frozen. And actually, I talked to Thomas yesterday about this. So this actually brings us to sort of a limits discussion. So Iot Explorer is now provisioned in any developer org, Trailhead Playground, Partner Edition, and it can be provisioned in production on a courtesy basis. However, what is it that you get if that's the case? In your DEs, you get 10 devices and 15,000 events. In the full version of the product, in the 2.10 release, which was released earlier in October, you get 10,000 devices and 500,000 events. Now, when you exceed that, we stop processing, which is what we were seeing actually yesterday, is that you would actually...
Our fleet is much smaller.
I'm sorry, what?
Our fleet is much smaller.
Oh, the device count. So again, this is a useful point. The devices and the events are independent. If you have a device, for instance, we actually had Google, when they were building on some of their partnership orchestration, they had an electric imp that was set to hit the endpoint once every 0.25 seconds. And that's a lot of events. That happens really quickly. They had like 4 of them. And you can burn through a lot of events that way, in addition to the API counts, which will probably get exceeded first. So, but yeah, limits are real on Salesforce, so we do respect them. Any other questions? Okay. We'll let you guys out early. Thank you guys for coming. I appreciate it.